So for a couple of days we were trying to understand SDWAN. Now let's focus on this most important page of SDWAN, the inner working of SDWAN. If you see the DTLS, the DTLS is a tunneling protocol. DTLS is a tunneling protocol. Um, this this is going to take a lot of control plane protocols inside it. A protocol like OMP or SNMP or netconf. So it's a tunneling protocol. Multiple protocols, they are routed through this tunnel, as I said, OMP or SNMP or netconf and so on. This DTLS and TLS tunnels, when do they establish and how long they are kept up? See, there are some tunnels that are going to be permanent, but some tunnels are temporary. Some DTLS, TLS tunnels are temporary, some are permanent. When vSmart controller, the vBond orchestrator, the vManage NSM, when the WAN edge device, when they all come together as a network, these tunnels are created between them. That is the time when authentication process between these devices happens. So these devices like the controllers and WAN edges, they get authenticated first through this tunnel. And then, as I said, the tunnel between the controllers remain permanent. The tunnel between the NSM, the vSmart, they all remain permanent. But the tunnel that is built with vBond and WAN edge gets broken once it is authenticated and enrolled. And the tunnel between these controllers, like vManage, vSmart, and the vBond, uses TLS. Whereas the tunnel between the vBond and the WAN edge will use DTLS, because the connection that we make is going to handle UDP traffic. This I also mentioned in the previous class. So that's about this tunneling protocol, DTLS and TLS. So what we have seen is inside this protocol, inside this tunnel, multiple protocol with many information is passed inside. Secondly, what we saw is these tunnels are established between the controllers and WAN edges as they come in to form a fabric. But a TLS can be used between the controllers. DTLS is used wherever UDP is involved. And connections, the tunnels are permanent between the controllers, but between the WAN edge and the vBond, the tunnel is broken down once the authentication is through. Next is the OMP itself. The decision maker in SD-WAN is vSmart. The decisions based on routing, access policies, the overlay routing domain. To build that overlay routing, the information is actually carried through OMP. Only with the information provided by the OMP, the overlay routing domain is established. Now, The vSmart is the one which is going to determine the network topology. How? By collecting all the information via OMP, it calculates the best paths to the network destinations. The vSmart calculates the best routes to the network destinations and then distributes this routing information to all the WAN edge routers. So the role of OMP protocol is also very important. And this OMP uses that tunnel TLS, DTLS. Now,
Any specific algorithm does it use to calculate the best path or something?
see the protocol that we specify on the vManage. Sorry, yeah, correct. On the vManage, we may ask to use OSPF or BGP or ISIS. EAGRP is not available as of now.
Okay.
So we specify through those routing policies through the vManage. Yep. So vSmart controller is the one makes the decision end of the day, because vManage don't collect those network topology information. OMP reports only to the vSmart. vEdges uses OMP to report to the vSmart. vSmart has got the complete picture of the topology. So only the vSmart can calculate the routes as per the policy to the network destinations and distributes this information to all the WAN edge routers. Okay, now OMP is a TCP-based extension control plane protocol. So this is a combination of control plane functions that are needed, and it's a single protocol umbrella. Repeating again, OMP, it's a TCP-based protocol, TCP-based extendable control plane protocol, which combines all the control plane functions under single protocol called OMP. All the control plane functions are managed by this one single protocol called OMP. So there is no other protocol needed for OMP. When we say OMP, it includes all that is necessary to carry out the route functions.
But this OMP you told it's based on UDP, right?
TCP.
It's not.
No.
Okay.
OMP is
No, but
TCP based. I said
no,
DTLS.
the DTLS and TLS, right? So between the edge to the controller, it will be DTLS, right? So it means it's a TLS. It's not TCP, right?
See, edge to the V bond is UDP. Is UDP.
Okay, edge to V bond is UDP. Okay.
Initially.
Okay.
Once they discover the neighbor,
Okay.
after discovery, it is going to be TCP. So the
Oh,
UDP,
okay.
the UDP based DTLS tunnel is broken down after establishing the adjacency.
Okay.
So
how about edge to then vManage and vSmart?
they're all
So
TLS.
okay.
TLS connections.
So initially it might be DTLS, then it will become TLS.
Correct.
Oh.
See, initially they don't know about VBond's whereabout. So it uses UDP, a kind of hello messages are sent and discovered. Once the discovery happens, authentication process starts. Once the authentication is done, VBond is going to provide the information about the vManage and vSmart, with which it can do a TCP-based connection. So only with the vBond it does DTLS, right? The tunnel to the vBond orchestrator is DTLS. Rest all TLS. So this is the only statement we need to remember. The tunnel to vBond orchestrator should be DTLS because the connection must handle UDP.
Okay.
All right. So that's about DTLS and TLS. That's over. Now we are in OMP. OMP is a protocol that is providing the control plane information by gathering the network topology, the networks across the topology. Using OMP, the WAN edges advertises this to vSmart, and vSmart decides the network topology based on the access policies. And this OMP is a TCP-based extendable protocol, which is a big umbrella of protocol that can provide you the control plane function for SD-WAN. As I said, it operates inside this DTLS connection, inside the tunnel. So first, comes this tunnel. First comes the tunnel, and then only the OMP sessions which is going to be carried, OMP session which is going to carry multiple information to the vSmart from the WAN edge devices. And not only that, vSmart sends multiple informations back to the WAN edges, which is going to determine the data plane and the transport. So between the WAN edge and the vSmart, there are various informations carried in between. Different type of informations are carried, and that is using OMP inside this DTLS TLS tunnel. So a lot more information are shared by OMP, not just like a traditional routing. OMP carries informations like routes, next hop, and then encryption key, and then policy information. The policy information, when I say the policy information that needs to establish the tunnel, the overlay topology, the policy that defines the overlay topology, overlay network. Right, so these are the informations that we can see the OMP carries. So the OMP peering is always between the WAN edge services or the WAN edge devices, and they exchange the control plane information between to and fro. But even though this determines the data plane, it provides the control plane which determines the data plane on the WAN edges. The traffics are flowing as per the guidelines of the information that is shared by the vSmart to the WAN edges. The vSmarts never sit in between. So they never do any sort of data plane functions. That's what I want to say. So the vSmarts, they don't care about data plane functions, they just provide the control plane information to the managers. Period.
This between the controllers, right? vSmart or vManage, they don't have this OMPs.
vSmart and
vManage.
no, no, no. But somewhere I read like some information from the vManage is directly given to all managed devices. Some route information which is common for all managers or passed on directly by vManage to managers. In that case, there are chances for vManage using OMP because basically it's a route information, it's a control plane information. But that I read in only one article somewhere, I remember, but I need to check those things. But usually OMP is the one which carries the route information, and the route informations are distributed via vSmart to the VANETs. That's the actual story. But in my early days, somewhere I read some route informations are global that are given directly from vManage to manages. If that is true, then definitely OMP should be between vManage and manage. Uh, I'll give you a clear picture as we proceed further in coming days. Give me some time. So now we are talking about this different protocol, and we are in OMP. So OMP is basically the route information distribution. Next, BFD. BFD is used only between SDWAN edge routers, and it provides the path liveliness. It is actually a quality management detection protocol. Quality man, no, instead of saying management, I should say measurement. It can measure the quality of the link of the tunnel. So quality measurement detection protocol, BFD. So it can tell you whether the tunnel is up or down, uh, how much is the loss of traffic, the latency, the jitter. Yeah. So between these WAN edges, we have IPsec tunnels, and this BFD protocol determines the up, down, loss, latency, jitter, and even MTU. So every edge router will be sending this BFD hello packets. This is the one which is going to help in measuring the quality and the liveliness of the path. So they send the kind of hello packets or echo packets that helps to learn the liveliness. By default, this BFD is enabled, which is going to measure the loss, latency, jitter characteristics of a data plane tunnel, IPsec tunnel. So whether we have some policies in vSmart controller or not, we might have configured, we may not have a policy configured, that doesn't matter. the performance of path, determining the liveliness, the quality, is always done. It is done automatically. As soon as the data plane tunnel is up, means operational between the WAN edge routers, immediately BFT will start running and provide the health measures of the tunnel. So, as I said, it is only between the WAN edges. As soon as they come online, as soon as the tunnel comes up, BFT is up. You don't need to invoke it, it is automatically invoked by every IPsec tunnel that is established.
It gives you the latency, all these things for the IP sector, not for the underlay, right?
No,
Only for
not
the
for the
overlay.
underlay, only for the SD-WAN overlay tunnel.
Okay.
But
Only that IP sector.
this BFD, which we are talking about, is, but in common. On the other day also we spoke about BFT. That time the discussion was what is BFT. So
Right.
usually BFD is to help routing protocols to take decisions faster. The routing protocols need not to wait for any timeout value to take a decision. When we enable BFD with OSPF, OSPF can be more fast in convergence because the BFDs are going to give the assurance if there is a path broken. BFD guarantees OSPF that it is truly a path broken, you can take another path. So the ping, the hello echoing between the BFD enabled device helps the routing protocol to confirm that the path is really broken so that we need to take another path. A fast convergence, BFD works on the physical as well. But in here we are in SD-WAN topic. We may have BFD enabled on the physical. Yes, of course you should have. When we have BFD on the overlay, and when we don't have BFD on the underlay, then it is not really justifying. So they are going to have BFD on the service provider side. The underlay transport, we don't know. We are not working on underlay. Underlay is a transport network provided by ISP. And I tell you, every ISP will have BFD on BGP
Okay.
and OSPF, ISIS. BFD can be enabled with all these routing protocols. So they are going to have BFD for sure under the underlay.
So it means there is a CLI to enable the BFT.
Yes.
Okay.
That is the underlay part, which we don't do. It is taken care by the transport service provider gives us. But here we also have good news that BFT is not only in the underlay, we also have it on the SD-WAN tunnels. So that's what we see here. We also have it on the SD-WAN tunnel. That's the information indirectly passed on to us. So every IPsec tunnel, when they come up, BFD dynamically comes up and starts providing the statistics, the liveliness, the quality of the tunnel, of the overlay. So once the WAN edge router securely connects to the other WAN edge router using a IPsec tunnel via the transport, transport may be via MPLS or IP network, that doesn't matter. All that we use is a T-log, right? So to reach the T-log, I establish a tunnel. So the transport doesn't matter. The T-log IP address never changes. It's just the tunnel IP address is what I mean, T-log. We ping through the tunnel IP address. I don't know whether I'm pinging through MPLS or IP. That doesn't matter because we don't work on underlay. It's the overlay. So through MPLS or through IP, somehow the tunnel is established. Now I need to know the quality of the tunnel. So BFT will automatically run over this tunnel. And it will start detecting, it will start gathering the loss, the latency, the jitter, and the path failure information.
Is there any special port that we need to open up? So if at all, if the edge device is behind a firewall or something, do we need to open up any specific port for that, or is it normal
These are all
TCP?
standard, normal.
Okay.
See, for routing protocols, for all these management protocols, no firewalls will block. Even for BGP, no firewalls will block until some extra configuration is done. The default will not block TCP 179. So there's no such thing like that. No, it is allowed. BFT is allowed. No need to additionally open any ports. Now, within an SD-WAN network, the endpoints the WAN edges wants to communicate, so the traffic needs to be directed. As I said, we may have multiple transports between the WAN edges. We may have multiple transports, but we cannot have multiple gateways because you have multiple transport. Without SD-WAN, for each transport you will have different gateway. Repeating again. Between the sites, between the WAN edges, we got multiple transport. If I go via MPLS, let's say the next stop is X. If I go via the IP route, the next stop is not going to be X. Not only that, the destination IP address also won't be same if I use different transport. But in SD-WAN, we are going to have same identification to identify the remote WAN edge. That common identification, whether you go via MPLS or go via IP, that one single identification to identify the remote WAN edge is what called as T-log, transport locator. You can imagine this as a tunnel IP address on DMVPN. Say suppose we have multiple connections to the spokes router in DMVPN scenario, and you are forming tunnel using loopback as a source. And you got a tunnel IP address also. The tunnel IP address is loopback. Or forget about loopback. You have given straight away loopback IP address. You also have an option saying IP and number loopback 0. Anyway, you gave the tunnel IP address, a private IP address, and you got two public connection. That doesn't matter, no. For DMVPN, you're going to use the tunnel IP address to communicate when you're using DMVPN tunnel. So even like tunnel IP address, we have here transport locator. So if I have SD-WAN with three different transports, I have three different transport. But the tunnel identification is going to be 1, inside which color is going to be 3. There's going to be 3 separate. So color only helps to differentiate the transport. So in that way we have 3 T-logs because the color is different. So T-log is nothing but it's a construct that creates the abstraction layer of the underlay transport link. It's the construct that creates an abstraction layer of the underlay transport link. So to explain this only, I was telling like we no need to use different public IP address if I'm using different transport. I use one common tunnel IP address. Then how will I know whether I'm going via MPLS or IP or LTE? It's color. So we use simply the color in the policy to say I need MPLS path. TLOG accesses, this abstract layer is what defining the IPsec tunnel ends, determining the topology, the overlay topology, right? So this information, that is the abstract layer that builds the secure overlay fabric on top of this public and private transport. Can be via MPLS, can be via internet, can be via LTE. So we don't really worry about what actual link or what actual transport IP address that we are using. Yeah. So
One question,
yes,
sir. Now,
please.
see, from your edge device, let's assume, as you were telling, right? So there can be multiple transports. So for the underlying transport, see, maybe I can use, as we have discussed, it can be either static or OSPF or predominantly BGP or AGRP is not supported. So it might be anything. So the physical connectivity will be based on IP now, correct? So
Yes.
that has an IP address which is configured based on what ISP is giving us. They'll tell, okay, this is the next stop and this is your address. So that is what we can use. Now, when you create a tunnel, right? So now you are trying to create a tunnel. So now when you are creating a tunnel, are we, see, like what you told something earlier, I just wanted to compare. So if you have a loop back, it would have used that loop back as the tunnel source, or if you have IP which is configured, which is obviously configured on the physical, so you will use that IP as the tunnel source IP address.
Mm. Mm.
Is that true?
Yeah. See, physical interface IP address is the means the additional layer 3 header. We are not talking about additional layer 3 header. We are talking about the actual layer 3, the inner header. The inner header destination address is always the tunnel IP address, the tunnel interface IP address. So here, SD-WAN TLOG takes care of all the outer header. That is what the actual inner technical explanation I should give for this. TLOG takes care of the bridging between the overlay and underlay. I will simply say I just want to reach that TLOG, means that tunnel IP. I will
It's
just
an
give.
additional header. So on top of the normal IP packet, there will be additional header which will be put in place with this address.
Yeah, the additional header is dynamically determined based on the color that we specify. We no need to worry about the additional header, what the source and destination is going to be. We only focus on the overlay information. Overlay information means the tunnel IP address only we need to know. And we also said this tunnel need to be created using color MPLS. When you say using color MPLS, vSmart says, oh, I know. Color MPLS, I know. I have already gathered the information about the MPLS transport via OMP. I know what encapsulation, the over additional encapsulation I need to do in order to provide you the service. So accordingly, the vSmart provides the information to the data plane in the edge device via which the tunnel is established.
Or the normal IP packet would be untest. Whatever things are there, everything would be there. So on top
Um,
of it, this tunnel adds one more additional header based on the color.
correct.
So if it is three different transports,
You will
and
have
if you are
three different
choosing,
colors.
yeah. So three different T-logs, and then if it is going via MPLS, it will be a different source.
Overheader, yes.
So if it's normal broadband or whatever, it will be different tunnel
Yeah,
source.
but we will
Okay.
not be able to see those things unless you are in a physical layer. If you're in a physical layer with a sniffing tool, you will find those things. The overlay will will only show you the statistics of the virtual topology. So if you want to see those things that you are talking about, you can see only if you are in a physical. When you sniff packet on the physical interface, you will see, but they will be encrypted. Only the outer layer you can see. If for MPLS it will be different, for IP it will be different, but the inner layer is anyway going to be AES encrypted. Can't see. Right. So
So to see this, sir, so to generally to see this, because I need to have a sniffer or whatever you told, right? I need to do a packet capture. So can I do something like I can do a port mirroring on different port, and then that port can be connected to my PC or some
why not? You can
Wireshark?
do spanning and all.
Okay.
We call the spanning. Yes, you can do that port mirroring. You can do that, but you are not. You're not. We are not going to see the inner layer 3, the original layer 3, because it's going to be
Yeah, that's
IPsec.
yeah. So that is fine, but I wanted to understand with the different transports,
Yeah,
will
that you
the
can see.
tunnel source keep change because it cannot be the same on the same transport,
Of
right?
course, you can see that. You can see that
Okay.
by sniffing on the edge devices. On the edge device, when we communicate through MPLS, when we communicate through IP, you will be seeing they are having different source and different destination as a layer 3. That will be
Okay.
there automatic. For some traffic, it will be A and B as a source and destination. For the other traffic, it will be X and Y, because the first one was time sensitive. We've sent through MPLS. The second one was not that important, so we sent through normal IP routing. Yeah.
So
Right.
that classification would have happened at the edge based
Yes.
on some policies, whatever it
Yeah.
is.
What vSmart has dictated
Okay.
to managers. So, so, so this SD-WAN fabric is built between various locations. The TLOG attachment point information also need to be advertised. So all the vantage also needs this TLOG information to be advertised. Now who takes care of it? As we saw earlier, it's the OMP. It's the job of OMP to register the T-log with the vSmart controller. And that makes vSmart controller to understand the map of SDWAN topology. And the vSmart itself exchanges the T-log that allows the SDWAN fabric to be built. So now the SDWAN fabric is built. OMP is responsible for learning the topology. How? As the T-logs come and register with the vSmart. Every device sends that this is my tunnel IP address, these are all my WAN IP address, I have MPLS, I have this IP, all this, it advertises. So that becomes T-log. So we already saw what this T-log carries, like next hop, color, and so on in OMP. So this information helps to build SDWAN topology.
Also see this OMP. So if we log into vSmart and then can we see those things? Information
In
also.
OMP,
So something like see show IP route will
yeah,
give you, right?
if we
So
will
similarly
use,
the
see again, it is encrypted one. It uses TLS. It goes inside the TLS. But to
locally
a
it should have maintained, right? See
certain
though
level,
if
we can debug and see on the command line.
okay. But locally it should have stored, right? See, the way that it
Show
sends
commands
might be
will show you.
encrypted.
Show
Okay.
commands will show you.
Okay.
But we don't use the CLI of vSmart, no. But we have access to it. We
Okay.
can try doing that.
Okay.
Show
Just to
commands will
understand,
show.
see, because vSmart will have, based on the topology, who should exchange what, right? So for us to have better understanding, if there is a way that we can see, typically show IP route will give me information, okay, who all are connected or who are
So
the replicas
definitely the
currently.
output should be there in command line.
Okay.
For that, we need to log on to vSmart's CLI,
Mm-hmm. Mm-hmm.
and we can see that. Um, Also, we can generate the command line running configuration of that in the vManage itself and see that.
Mm-hmm.
Yeah. So the fabric is built basically by exchange of T-log information. Right. So the topology, sometimes it may be a full mesh topology, a hub and spoke topology. It all depends on the advertisements and distributions of T-log. All right. So that's about this page. And we have gone deep into this one more than what we see here. Now, this is also spoken. This is also spoken. This is also spoken about BFT. This is also spoken. The T-log information are shared. Just now we finished seeing. Now this is the page we need to focus. The system IP.
No, back slide. So you had mentioned OMP update, but okay, this is between vSmart, not V1, right? Okay,
Yeah,
because that is stayed off. This will continue. Okay,
correct.
okay, okay, carry.
So system IP. System IP is persistent, meaning it's a unique identification for a device, not interface. You can compare this to a router ID in OSPF. So the system ID must be unique, and this is the one which is used for all overlay operational operations. But one good thing is, like OSPF, router ID is not necessary to be a reachable address. The system ID also need not to be a reachable or a readable address. We need an ID. So it need not to be a reachable address. It's an ID for the entire device, not for the interface. But it should be like in an address format, same like what we have the constraint in OSPF. Yeah. So it's recommended to make site more. Sorry, system ID is recommended because the site can be easily recognized. The sites can be recognized. But system ID, system IP, not system ID, system IP cannot identify different circuits. To identify circuit, what we have is color. Repeating again, this is not WAN IP address. System IP is just to identify the sites, period. How we reach the site, what is the WAN IP, those things are not those are not a system IP. Those are colors. So color is used to describe the type of circuit. It is not the system IP. The color is the one which is going to differentiate different transport that we have. Maybe MPLS or internet or LTE. And also it is the same color that tells whether it's a public transport or a private transport. So by default, the data plane tunnels can be established across different colors as long as they have reachability to those T-logs. We may go through MPLS or can be through anything. As long as the T-log is reachable, the tunnels can be established via any transport. So in SDWAN, we have a very large number of predefined colors that when we go further we will see. So that is the first thing, system IP. System IP helps to easily identify a site. This is not.
Yeah, so this is also carried as part of your T-lock information.
Yeah. Yes.
But why IP address format is required? It could have been any number as well, right?
See, usually, when we use IP address, that uniqueness, when an IP address is picked up from a device, that's going to be unique, no? There are no
Correct.
routers or no device with same IP address within a domain. No one will do that mistake. No one will give two devices with same IP address if they want to communicate. So when IP addresses are unique, if you take that IP address and use it as a system IP, then your system IP is also going to be unique.
Unique.
That's
But
the
what I'm thinking is, see, if at all, if the customer misconfigures, he forgets that whatever system IP, maybe from his internal private network also, if he's having the same IP.
should not have, no, that's a mistake.
Mm.
So the reason why it is in an IP format is so that an IP address can be used as a system IP. Because the IP addresses are unique, we can use system IP address as a system IP, so that system IP also will be unique, so that we can easily identify a site.
Yeah, we could have used loopback as well, right? See, that would have also be unique.
End of the day, that is not going to be used as a system IP. If you don't mention, it, it is going to use the loopback, same like OSPF and BGP.
Oh, okay. If I don't mention, then
Yeah. Now that is about the system IP and the color. We have spoken about color. We have spoken about system IP. Thirdly, we have domain ID. As it is said here, it's a logical grouping of WAN edge routers and the vSmart. So within a domain, WAN edge routers can connect to other vSmart controller in their own domain. So WAN edge router should not talk to some vSmart. It should talk to its own vSmart in the domain. So within the domain, there is a full synchronization of route information among the vSmart controller and the WAN edge router. So organizations can use the domain to divide its network according to different business unit or other business requirement. So if you don't have a domain ID, then you will not know to which controller I am talking, to which vSmart controller I am talking. So it is necessary for us to have domain ID so that we will communicate to the right vSmart. If you have multiple business units, for each business unit, we need different domain and different vSmarts and different group of edge routers. So domain ID is important. It is a logical grouping of WAN edge router and the vSmart controller. Simple. So the domain may be a very big, large domain for a big geographical area, or it can be a domain used for a data center. But domain is domain, helps to group small or big. So dividing the network into domain provides aggregation, summarization. Like what we have, multiple areas. When you have areas in OSPF, you get a summarization point. You have an aggregation saying these are all area 1 network, these are all area 2 network. Same like domain ID is like an area ID in OSPF. You can compare like that, but this is my own statement. Domain ID is like a area ID in OSPF. All right. Lastly, we have site ID. So you can use any number between 1 to 4294967295. It is to uniquely identify site in an SD-WAN network. Just one site. See, domain ID has got multiple sites in it. One domain means multiple sites with vSmart domain. So site helps to identify, site ID helps to uniquely identify a site in an SD-WAN overlay network. For WAN edge routers in the same site, the site ID must be same. Of course, it should be. If I have multiple WAN edge routers, all the WAN edge routers must have same site ID so that they can say I belong to this site, like an area ID. Every router in area 1 will have area ID 1. So likewise, every edge router that belongs to same site should have same site ID. Site ID is needed for the WAN edge routers to get authenticated by the controller when they are attached to this SD-WAN overlay network. So by default, the IPsec tunnels are not formed between the WAN edges within the same site. Why? They belong to the same site. Why there is need of an IPsec between the WAN edges? So It's the site ID that helps to avoid forming IPsec tunnel between the WAN edges of the same site. When the site ID is same, yeah, not necessary, but it doesn't mean that it is not possible. If you want to have, you can extend it and have it. So WAN edge routers that have got same site ID do not share the T-log information, and they don't establish any BFD tunnels between them because there is no IPsec. So no T-log information is shared, no IPsec tunnel is established, no BFD between the edge device that are having same site ID.
Just once tell about this domain ID. After you told the site ID, slightly confused.
Domain ID is simply to group all the WAN edges and vSmart. All the WAN edges and vSmart that belong to one business unit is identified with domain ID. Domain ID is not for one site. Domain ID is for the entire SDWAN fabric that belong to one business unit. Whereas site ID is only for one site. In one site, you may have multiple WAN edges for redundancy with VRRP. So you will not be willing to establish any tunnel because it is within the same site. So no T-log information is shared between the WAN edges that has got same site ID. No T-log, no BFD, no IPsec.
Okay. So when you compare this with some multi
No, that
this
is what the
service.
problem is. In ISP, sorry, in OS.
No, not this MSPs would be there, right? Say they provide this service provider, and then they tell, okay, we provide this infrastructure. So it means they will have multiple clients.
Yeah.
So at that point of time, so this domain ID is for one organization. Let's assume that
Correct.
they serve for Wipro. So so they will have one domain ID which is unique across across Wipro, and then Wipro might have multiple branches in Bangalore or Bombay or Delhi. So it means they will have unique site ID.
Correct.
Bangalore is one site, Dubai is one site, or something like
Yeah,
that.
but the domain
And
ID will be same.
domain ID would be same because it's for the same organization,
Correct.
Wipro. Okay, okay,
Correct.
okay.
Correct. So basically, the site ID is to identify the site. If I have multiple edge routers, between the edge routers, they need not to communicate. And also, this helps to shape the topology, like hub and spoke. All right, so choosing site ID for a network, you need to be very careful, choosy. Why? The site ID will also be used when you apply policy. Policies are applied to list a range of site ID. So planning of site ID is important because the site ID is going to be used along with policy. So it should not conflict with any other policy IDs or site IDs of other organization. All right. So we stop here with